be helping you guys out with the definition of your project and supporting you through it. Deepak on the call here is the author of PRU Speak. He did that as a Google Summer of Code project. And I'm just here to try to demonstrate the current status of PRU Speak primarily, and then answer any questions that you might have about the project definition, continuing Lucas's work to get the Arduino library ported over, plugging that into the PRU Speak interpreter, getting that into a web page interface for typing in commands into the interpreter, and potentially using some of the starterware library function implementation in order to help speed your development. So those are all the kind of magical code pieces in place.
Okay.
And then I just want to kind of start off by showing you the PRU Speak. This is what I'm in right now. I'm actually logged into a bash shell on the board, and I've got checked out through. So this is through the Cloud9 IDE. This is what it looks like when you normally just browse to the board over USB and open up port 3000 where the Cloud9 IDE is. And down here at the bottom is just this login shell. So I can edit all my files here. I can see here, if I go here, I can say show the root file system, and this allows me to see all the files that I have in my root directory.
Okay.
And you can see I've got this PRU Speak that I have I checked out from GitHub using Git. So the boards ship with Git on them. I'm using the 514 Debian image. I don't know if you can see that clearly. I can't seem to find out how to increase the size
I think we can read it. It's fine.
It's readable, okay?
Yeah. It's fine.
Yeah,
okay. Okay, cool. So that's the image that I'm using, and I've just got the PRU Speak library there. Let me check out Deepak's version because I'd actually made some changes to it. So let me just abort those.
So is PRU Speak an interpreter written in JavaScript that takes Botspeak commands and runs them on the PRU?
No, it is an interpreter written in C. Well, there's two different portions of it. There's a tokenizer that takes the kind of assembly-looking source of the Botspeak language itself, and puts that into almost like a bytecode, but essentially it's just a tokenized representation of the source, and then a C application that runs on the PRUs to actually perform the interpreter operations. So it's not written in JavaScript, but the idea is to eventually create bindings such that you can generate the code from JavaScript, just like there's bindings today to essentially create the code from LabVIEW.
Okay.
Do something similar from Python or from JavaScript. It's essentially generating that Botspeak code. Today, the tokenizer is actually isn't written in Python, but my intention is to rewrite that entirely in C and put that into the Linux kernel. That's my roadmap for that, and that may be a bit much to ask you guys to do. That's something that myself and Alexander Haim are looking at doing.
Okay.
using tools like Flex and Bison. I don't know if you're familiar with those. Actually, just Flex, right? So, which is just a lexical analyzer. The way that Deepak's implemented it currently, he's using essentially a Lex library in Python to perform the tokenization. But we just switched that into using Flex, which would generate C code.
And go ahead.
Oh, go ahead.
I'm sorry, I have so many questions, but so the pseudo bytecode that's running on the PRU, is it the Python program sort of writes into shared memory, like here's some new pseudo bytecode that just came in, and the PRU is constantly looking for that, and when it sees it, then it runs something? Is that sort of how it works?
So it listens to it in a few different ways. So if you look at the source, I don't know if I can, oh, I did, I can blow the whole thing up. You'll see that this is broken down into a few different areas. The driver is the Linux kernel driver. The DTS, this is the device tree. What this does is this is used to provide information to the kernel about loading the driver and about configuring the driver and information about loading the firmware using the driver. Right. This is essentially a parameterization. If you look in here, there's this this PRU speak file. This is a data description that configures the I/O pins and essentially tells it configures the PRU and tells it what firmware to load. So that's a configuration. This is the actual driver source that allows the communication between the Linux system on the ARM and communication to the PRUs.
Okay.
Then there's the PRU firmware. So this is the C code that's actually running on the PRUs.
Okay.
There are two PRUs in the system. One PRU is dedicated to running the interpreter. The other PRU is there for running essentially extraneous real-time tasks. So say I wanted to implement a pulse width modulator, and I ran out of hardware pulse width modulators that I can use. The second PRU can do a software implementation of a pulse width modulator. So essentially that other PRU is just sitting there and it's monitoring state and doing whatever real-time tasks need to be offloaded from the main interpreter.
Okay.
And then this user space lib. This user space lib becomes the sort of the primary interface to the end user as of now, and there's different interfaces that it can provide. What says here? Oh, that's the compiled code. What it's called here? It's calling the compiler. Well. Oh, okay. He broke it into a PRU speak subdirectory. It's really just so I guess he renamed it from being compiler. It's no longer a compiler, right? It's just a lexical analyzer, right? So this is these are the keywords that it uses in order to tokenize the Botspeak script.
Okay.
And then, so this, if you look over this Python library, it's essentially just converting the source input into just a collection of 32-bit words that get sent down to the PRU.
Okay.
Then that's the overall top. And then those get called through, if you want to interface with it like a shell, you could just start this shell command, and then it'll give you a prompt here that you can type in commands individually. If you want to start a script, there's some keywords reserved um, for starting a script. So you do you type in script on one line, and then you type in several different commands, and you type in script, and then you can type in run to actually run the script that you've loaded. And it's always able to continue to take additional direct commands, and that's what provides you with the ability to go and update variables and do communications with it, right? So you can you can go and look at the status of a variable or write to a variable, and that provides you ongoing communication between the ARM and the PRUs.
I see.
But you can also set up a TCP, so you can just do it directly from a shell where you're taking input from standard in and providing output back to standard out. But he's also implemented a TCP server, right, where it opens up a TCP port where you can send commands, and that's generally how LabVIEW would talk to it, right? So LabVIEW would you'd point LabVIEW to the port on the board that you're using, and then it would send Botspeak commands.
Okay, yeah.
So that's the basics of the architecture. I haven't unfortunately played with this recently. I don't know. Deepak had to run off. So hopefully, if I just run this, it'll work.
So you talked about adding some libraries. Is there any libraries that are already on for PRU Speak?
Yeah, there's several functions that are implemented. They're not really. I don't think they're broken out all that necessarily clean, but if you'll see, this is like the DIO handler. So this is partially implemented. This handles doing digital input and outputs. I'd note that this is only currently doing digital inputs and outputs using the direct mapped registers. So if you look at the BeagleBone, I'm going to try to bring up a collection of the pins. There's a bunch of pin headers. There's different pins, but only some of each of these different individual digital pins has 8 different modes. Actually, you know what? I've got a better tool to actually help illustrate this. This is the can you see the BeagleBone Universal I/O configurator?
Yes.
All right. So this is so you have all these different pins, right? Well, only a certain number of the pins, like say if I highlight these ones that say PRU out, those pins are directly accessible through the R30 register. So if you select that MUX mode on these pins, it would directly represent R30 bit 12, R30 bit 15. So if you see those numbers here, so depending on whether it's PRU 0 or PRU 1, and then so let me explain the whole nomenclature here in the pin names. The PR1 is you can pretty much ignore that. That's just a prefix for the PRU pins. Then you'll see PRU 0 or 1, and that tells you whether or not the pin's accessible from which PRU. And you'll see PRU and then R30. All of the output pins are driven by the R30 register directly in the CPU. And then the last number is the the bit within that register. So these are the ones that you can do the fastest and kind of the easiest from the PRUs. But you can also access the other modes of these pins, right? You can actually use things like the PWM peripheral. So several of these pins have PRUs, or sorry, PWMs or pulse width modulators tied to them, or things like UARTs. So you can talk to those peripherals, but those essentially, you have to go and configure the peripheral in order to talk to these, whereas the other pins are ones that are directly tied to registers. And similarly, there's GPIOs. There's a whole bunch of GPIOs there's a lot more GPIOs than the ones that are just tied directly to the PRU pins. So you can put those pins into a GPIO mode and speak to them that way. So it's a bit slower, but it's still pretty fast. I think it takes in the order of about 6 to 8 cycles or something like that to do an update through the GPIO register, whereas it's a single cycle update through the PRU pins. Different collection of pins for input.
Okay.
And so you just kind of, if you look at his code that he has right now, he's just got the direct tied pins implemented.
Yeah.
Ultimately, there should be a mechanism for getting to the other pins as well through the GPIO module, and that's where some of the other library work should come in helpful, but it hasn't been done yet here. You can see that he has done some work on using. I'm not sure if these PWMs. I don't know if Deepak is around, but I don't know if these pins are using the other PRU or if they're actually using the PWM hardware module. What it looks like to me is that these are probably using the other PRU in order to do the toggles. So those are also just, these are essentially doing software PWM and not talking to the PWM hardware block.
Okay.
Array handling, so all the different if handling. So the basic data flow and basic operations are all through here, and there's not something else. There's not an extra library of all these different functions. The best place to kind of start looking at those is that the library that I pointed out, which is the starterware library, and there was a GitHub repo that I pointed out to you that was for it was initially the Beagle pilot folks, people creating an autopilot using the PRUs had done evaluation of it. And essentially they were taking the library that's intended for the ARM to communicate without an operating system to these peripherals and moving that over to the PRUs. They did some initial proof of concept and saw that it was working, but they didn't test it all out.
Okay.
And that was that PRU SS-C project. And if you need any of those links again, I'm happy to send them on to you again.
I think I got them. And
then, in addition to adding ways to get to the other pins, what other functionality are you looking to add to the PRU speak using other libraries?
So what other functionality is there besides the libraries? I mean, I would be pretty happy. So passing level happy. If the we got just the additional functions of using these different hardware modules implemented and interpreted and integrated into this existing interpreter.
Okay.
Kind of the next priority beyond that is getting it into that web interface that I don't know if you've seen. How do I find my applications?
Is that what you sent us the other day? That you can select the device that you're going to work with and connect to it, and
The Chrome extensions project.
Yes, well, I think so, but let me just run this to make sure. It's essentially this interface.
yes.
Now you talked about running that on the BeagleBone instead of.
Right.
So would that be on the ARM?
Yes. Let me show you an example of that. Actually, so this is actually running off of my connected BeagleBone.
Okay.
And when I did this, it actually went and downloaded a program into the into this auto run folder. It should have. Oh, there must have been an error. Connection refused. All right. So I've got an error in my code here somewhere. I'm not quite sure why.
Well, right now, this Botspeak would be running on the ARM. Is that right, Jason?
Yes. In fact, this is running the web server would be running on the ARM. The Botspeak code itself would be running on the PRUs. This implementation is one that runs the Botspeak interpretation on the ARM, and that is in JavaScript. But that's not we wouldn't want to be using the JavaScript version. We want to be using we want this terminal talking to the interpreter running on the PRUs.
Okay.
So we get tokenized on the ARM, but then it would get all the actual commands would get sent down to the PRU for execution. And the huge advantage of that is that means that instead of them taking up ARM cycles and having unpredictable timings, that they would all be extremely reliable timings because they would be running on a dedicated processor and not chewing up the ARM CPU cycles.
But I guess the whole program would have to be downloaded to the PRU first then, because if you're just waiting for each line of code to come in before you can run it, then you're not going to get that reliable timing, right?
Correct, but there's so the way when you want to send a script down, so you start with script and then you do say set BIO 0 to 0, you do wait. And that would essentially be what you type in. I guess right now I don't have a connection to a properly running Botspeak interpreter, but this is what you would do in order to create a like an LED toggle loop right here.
Okay.
And you could do much more, much richer scripts than this. So you can type individual commands that get sent down to the interpreter sitting there running on the PRU ahead of time, but it doesn't have a script to run. And so by sending these individual commands, you give it a script to run. And you can see here you can build up, a full script.
Okay.
And if I could use other environments for programming it, this is kind of the lowest level environment for programming it. And this becomes a kind of an initial education point where I have this interpreter. It's it's just running reliably when I just plug in the board and browse to this address and I just go. And that becomes kind of the intro to programming paradigm, and then you start building up richer scripts, and then you go from there, and you can start building out to other languages, actually generating this code and build upon that. And then if you want to start getting below the scenes, you can start looking at how the interpreter is implemented. Start using the C library to extend the functionality of what you're putting on the PRUs, add additional commands. So I still think that this is the right initial user entry point, and then it opens up a huge amount of different of programming paradigms for users coming to this.
And this is the Chrome extension in JavaScript.
This is done without the Chrome extension.
Oh.
This is actually being served up by my board itself.
Okay. Would we be designing our own in something else, or what would that look like for us?
So you can simply extend this code.
Mm-hmm.
So if you look at the boards, there's this in this varlib cloud9 IDE directory is the source to like whenever I browse to the board, just open up its IP address, it serves up this page.
Right.
And you see this fork me on GitHub button. That takes you to the GitHub repository for the source to that. And you can see under here examples, extras, Botspeak. That's the JavaScript Botspeak code. And what would have to change is instead of sending the commands to the JavaScript interpreter, is that you'd want to send commands to a port on the board.
Mm-hmm.
And that would essentially be the PRU speak, which Deepak has already written.
You could start with that. It would be, right? Yes, it would be. And
Okay.
then you just want to extend that with additional commands.
Right.
Kind of finishing out the language. But yes, it would be just talking to the interpreter that the Deepak has already created. And I want to show you that is all copied to the board and available through this varlib cloud9 directory. So if I look on the board itself, right, I see this similar source, right? So examples, extras, Botspeak, and there's that page. It still says title of the Chrome extension because I took the code from the Chrome extension.
Mm-hmm.
The advantage of the Chrome extension is that it allowed direct communication to serial ports and to TCP ports. But given that we have that ARM Cortex A8 that's sitting there, we can use it as kind of an intermediary to serve this up for us, and we don't need to use the Chrome extension.
Okay.
So you can go back and reference the Chrome extension and look at using that if you'd like to, but you can also just kind of jump straight to serving this up directly off of the board.
Okay.
Great.
Kind of a off-topic question. We will need to get a couple of Beagle bones to working on this. How can we? How do we request those? Do you? How do we get hold?
I can I can order those for you. You know, the first thing I do is look at if Special Computing or Adafruit has any in stock. So Adafruit does have boards in stock. Um, I can simply place an order for you. Come on. And have them sent to your location. So it looks like Adafruit has them. I'm sure Special Computing likely also, yeah. So Special Computing also has them in stock.
Okay.
So yeah, just tell me how many you need and what address I need to ship them to, and I'll have them sent to you.
Okay, great.
Okay, we'll send that to you. And then it looks like a lot of the code that we'll need is on the board, or we can get it from GitHub. Is there anything else? Any software that we'll need to have access to, or is it all pretty much open for us?
We do everything open source with BeagleBoard.
Okay. Great.
I guess LabVIEW wouldn't be, but
Oh, I'm sorry. Yeah, I misspoke there because everything that you need to implement and actually where you need access to the source code is all open source.
right.
For the LabVIEW integration, yeah, I'll you let me know how many licenses you need, and I'll speak to my contacts at LabVIEW and get them to provide you with a license. You know, that shouldn't be a headache at all. Just let me know.
Okay.
You know, Chris Rogers' VIs are public. You look at so VIs are the let's see, trying to figure out the best way to show those. Thought you'd have some pictures of his VIs.
Yeah, maybe language sample codes.
Say again?
Yeah, that's it. I see it now.
You're right. And so this is a picture of the LabVIEW window. And so he provides the blocks that you need to download in order to make these things work. And so this would be a Botspeak application written inside of LabVIEW. And so you know, we could take some of his examples and just run them in order to verify that the integration is right.
Yeah.
Okay. Sounds good.
And this is where it really gets to be powerful, right? When you start doing things like proportional integral and derivative control, right? So proportional control, you know, here's the system. The idea being that, you know, this makes it really easy for somebody coming from different disciplines, you know, say their discipline is mechanical engineering or other things, so that they can program these devices and have them behave in real time and not really bother understanding all the low-level programming details.
Right.
That sounds great.
Okay, well, I think that's all the questions I had for now.
Yeah, same.